thread. So what do you mean by thread? It's a lightweight process. So threading, it's nothing but it's a lightweight process. So what is the advantage? There are, what do you mean by multitasking? So there are multitasking means parallelly you can do some kind of task. Multitasking means parallelly you can do some kind of task. So right now consider, for example, so now for example, if I'll consider a particular multitasking. So if I'll write down multitasking, multitasking. So it is very difficult to write. So that multitasking, if I'll define, there are two types of multitasking is there. One is that in process level multitasking. One is process level multitasking. So this is that process level multitasking. Another, we have multitasking in thread level. THREAD. In we have that another type of multitasking. That one is in process level. Another one is that thread level. So in process level multitasking means what? For example, right now, two or more number of process it's going to be execute. Two or more number of process, and for example, right now, while working or writing something in Microsoft Word, at the same time you can listen that particular song also. Or side by, you can say that you can watch some kind of movie, and after that, in that same system itself, you can write some write or can do some other task. So not only these things, for example, best example you can take that while writing something in Microsoft Word, at the same time that spell check also it's running. If there is any kind of spelling mistake is there, so at that time it's going to suggest you, oh, there isn't some mistake in this spelling. So these are that some of the tasks. So these are that multitasking. Okay, so this process level multitasking means it's going to be supported by operating system. So right now, programmer, this is supported in process level multitasking. It's supporting in operating system level. So now if you'll go in your system, you can see that now if you'll go to your system, here you can see that, for example, task manager. So in this one, you can see that n number of process it's going to be, n number of process it's executing. So some of the process, so you can, it's not only one process, more than one process it's executing. So this is the process level multitasking. So process level multitasking, it's going to be supported by operating system. That means more than one process it's going to be execute. Now thread level multitasking, it's going to be supported by program. So thread level multitasking, it's going to be supported by program. So what we told that there are two types of, one is that process level multitasking, another one is that thread level multitasking. So now in this thread level multitasking, what happened? In that program level, so you have written one program. For example, right now this one is your program. So in this one, n number of instruction is there, or n number of line, or n number of code is there. Now all the code, it's not going to do the same task. Maybe this part is doing some task known as A, and this part it's going to do that another task known as B. So right now within this particular program itself, I have divided this whole the information into two parts. So this is independent and this is also independent. So this terminology has to be understood correctly, that A is independent of B and B is independent of A. That means A is not dependent on B and B is not dependent on A. So we'll say this one is an flow. So this is an one program flow. So A is an one flow and B is an another flow. So there are two numbers of flow is there in this particular program. One flow is known as that A, another flow is known as that B. So right now, if I will write a program by using thinking one. So right now, you know that program it's going to be executing line by line. First, this line will execute, this line will execute, this line will execute. Like this, if there are suppose 10 lines is there. So to execute this particular 10 lines, you need 10 minutes. You need 10 minutes. So I'm not thinking. So now this 10, let it be 10 million codes. Now this 10 million code to execute 10 million, the time also will increase. Now see that all the things it's not doing that same task. All the part of this code, it's not doing that same task. So for that reasons, what we can do, we can divide this program into two parts. This is one part, this one is that another part. So this part will be executing by one, and this part will be executing by another one. That one is nothing but by one thread. We'll consider that one as a thread, and this one is going to be executed by another thread. Now you see that now the code is going to be divided. So 5 lines is executing by T1 and 5 lines is executing by T2. So right now what happened? Parallelly T1 and T2 it can execute. So while executing this 5 line, I no need to wait when that 6 line will start. At the same time, that from 6 to 10th line also it can execute. So if it is doing like this parallelly, if it is executing, so at that time you can think of that it will take less time, isn't it? Will it take less time or not? Now suppose somebody has given your task to write 100 question. Okay, and each 100 question, first 50 questions is related and next 50 questions is not related. So what you can do that instead of assigning all the 100 question to write by only one person, if I'll give it to two different students, so they can finish it early. So to write where to write 100 question when it will take that 5 days time, but if I'll divide it into two part or two students, so at that time it will take only 2 to 3 days. So this way what will happen, that time, that how long time it has to take, so it's going to be reduced. That it's going to be reduced. So a program part in a program, if there are some kind of independent, so if there are n number of lines is there, and for example this part are independent from this part, so we can keep these things into in one thread, and I can keep this thing into in another thread. So if you'll do it like this, it will reduce execution time and it will execute fast. So now where it's required in typical software development. Okay, so somebody if will ask you that there are some kind of information is there, you go and you write a program to search that information. But at a time, if you'll write one simple program to search, for example, right now this is that file. So in this file, from this file, I have to search the name starting with word A. Okay, so now each and first 100, first this part is independent and this part is independent. So if I'll write only one program, or if you'll write only one program to search, so it will take much more time to find out all those names, whatever the names will be starting by A. Instead of this one, instead of that one, if two things is going to be assigned, it will obviously reduce my time. It will obviously it will reduce my time, so that we can create threads. So one thread is responsible for this code, another thread is responsible for this code. So we can execute both things parallelly. So we can do that parallel execution. So in this way it's going to reduce the time. So now in this where it's going to be differed. So right now you can see that whole the things will be write it into one space, so that memory space is going to be shared by both the thread T1 and T2. It's going to share that both the thread. memory space. Now you go to that another example. For example, right now, let me open any kind of browser. So if you'll open a particular browser, for example, this one is in one browser. So in this browser, I have different things. Here one song it's playing, in this plus one image is loading, in this one video it's loading. Here user has to write down their username, here user has to write down their password. After that, here sign in button will be there, and there are some other information. Lots of things is there. So right now, each and everything to load, if it will take more time, will you agree? Will not agree. So you will not use that website on the next day itself. You are not going to use that particular website. So here also we can think. So this part is going to be executed by one thread. This part is going to be executed by one thread. This part is executing by one thread. This part is executing by one thread, and this part is executing by another thread. So this is 1, 2, 3, 4, 5, total 5 thread parallelly it's running to display you that particular website, So at that time, it will take less time, but only if programmer is writing with only one thread. So you can think, first one video has to upload, and after that audio has to upload, after that some text will upload, after that some image will come, and after that your username, password, and sign in, these buttons, all those things, it's going to load. So it will take more time. You'll next day itself, you will not wait. So right now, no one wants to wait something if it's too slow. So for that reasons, if we can use the concept of multiple threading, it will take less time. So within fraction of second, because everything it's parallelly, it's going to execute. Now think of, you are playing game where this thread it's going to be used. Now while playing any kind of mobile game and all those things, any kind of video application, any kind of gaming application, this thread concept is very, very important. So while any kind of game, at that time you'll see that you are moving one part from somewhere, one part is coming. So different kinds of images is coming. If you'll go for any battlefield game and all those things, there will be so many armies will be there. So each and everything, if it is not an one thread, sorry, if it is each and everything, if it's all together a single thread, so you can think of to load that particular game or to do those movement, how long time it may take. So instead of that one, multiple thread it's creating, and multiple thread parallelly it's executing. So you will not come to know itself. Is that clear? So you will not come to know itself that which thread is first executing, which thread is second executing, or third, but everything it's parallelly executing. So this is the most important concept, that why we are going to use this particular thread. Now any kind of movies. So in a video graphics, so in a graphics, you can see that multiple component or multiple what you call that, multiple images or multiple tasks together, it has been framed. So each and every task has been handled by one separate thread. One separate thread, it's handling each and every task. For example, if you'll take same kind of scenario, for example, right now in this one is in one screen. So in this particular screen, this is one. Next, this one is that one image, this one is that one image, maybe here some villain and actor, actress. So there are many more people is there. So right now, each and everything, it's not going to be handled by separate thread. Only one thread it's going to handle it. So at that time, to load each and everything, it will take much more time. So instead of this one, what it can be done, that each and every component, whatever that component are independent, dependent component, it can't be executed by different threads. If the all the component is independent, so at that time we can execute that independent code or independent part of that program by a thread. So same here, I am coming again to this particular program. So this multitasking, having two things, process level, it's supported by that operating system. I can't write any kind of things for this thing. Right now, no one, I can't write it. So this is also known as that multitasking, and in process level it's supporting. Next one is then in thread. So thread level multitasking, it's supporting in your program. So a particular program, if there are n number of code is there, some of the code will be executed by one thread and some of the other part it's going to be executed by another thread. So in this way, we are going to reduce that time. Is that clear? Is that clear or not? So this is then flow of a particular program. We can divide the flow of a program into multiple parts depending on their task, if those tasks are independent. Is that clear or not? So here you can see that thread, single sequential flow of control. Thread, it's nothing but it's a single sequential flow of control. So this is sequential only, 1 line, 2 line, 3 line, 4 line, 5 line. So this is that single sequential flow or control within a program. Now this is another flow. This is another flow. It's a sequential flow. So this is one flow. This one is that another flow. So there are two different flows there, and both the flow is independent. They are not, this flow is not dependent on this, or this one is not dependent on this one. To load your video, it's not dependent on to load your audio. To load your audio, it's not. Now Microsoft Mozilla Firefox having it's also providing by thread support. So you just search into this one, that how many numbers of thread it's supporting in browser, Firefox, or what you call that, Chrome, how many, or Safari, how many numbers of thread it's supporting. Whole the web page, it's not going to be load by only one thread. So whole the it's going to be defined by different threads. So a single threaded program can handle one task at any time. If you'll define this one as a single thread, so it's going to, so this whole the things, if it is single, so that means one single thread. So single threaded program can handle one task at any time. So by default, there is an one thread is there in our program. Till now, whatever programs we did, that by default one thread is there. That one is nothing but one thread. That is nothing but main thread. Name of that particular thread is main thread. So multitasking allows single processor to run several concurrent threads. So you can see that multitasking. So this multitasking in two ways. One is that process level multitasking and thread level multitasking. So multitasking allows single processor to run several concurrent threads. So multitasking by with that is single, in this process, nothing but there are n number of CPU is there. So if you'll go to this, so you can go to this particular thing. So here you can see that this is that multiple processor. One thread is executing in this one, another thread is executing in this one, another thread is executing in this particular processor. So that multiple threads on multiple CPUs and multiple threads sharing a single CPU. You have studied this, what you call FCFS, shortest job first, SJF, STF, round robin. So this kind of scheduling algorithms you have studied, you have seen that one single process only, you are going to scheduling the execution of a process. Now scheduling the execution of a thread. So thread 1 will take this time. Once it will finish, thread 2 is going to start. Once it's finishing, thread 3 is going to start. Once it's finishing, thread 1 again remaining. So this one, why it's depending. So there are two types of scheduling is there. One is that preemptive scheduling. Another one is that non-preemptive scheduling. So preemptive scheduling means what? If any kind of emergency, for example, right now, through a particular road and minister is coming, then at that time in traffic signal, what will happen? That minister will get that priority. So others who are moving, they have to preempt, they have to stop. So that is preempting. For example, maybe thread 1, in this case, someone has come who is more important. So at that time, what happened? The thread 2 is getting more important. So thread 1, it's going to stop it here only. You'll give chance to thread 2. So now thread 2 once finished, after that thread 3 also has come, who has also more importance. If he has finished its task, then what will happen? Again, the thread 1 will start execution. After finishing this, again thread 2 will start execution. So we can preempt a particular thread. In case of that non-preemptive, until or unless it's going to finish its work, it's not going to stop. So this is that concept of thread. This is multitasking allows. So this line only we was in this line. So multitasking allows single processor, only one processor to run several concurrent thread. So this is the diagram. Here only one single processor is there. So it's a time sharing process. Okay. One time will be given to thread 1, another time will be given to thread 2, another time will be given to thread 3. After that, again thread 1 will get chance, again thread 2 will get chance. So now if multiple processor is there, you can see that one thread it can execute in this processor, another thread will execute in this processor, another thread will execute in this processor. Both things is doing parallelly. But in case of that single CPU, it's going to be scheduling by that scheduler which one has to execute. So this is only multitasking allows single user or allows single processor to run several concurrent threads. Modern operating system supports multitasking. So as you know that most of the operating system, whatever nowadays we are using, so all those things it's supporting multitasking. So advantage, already you came to know that what is that advantage, that response time will be less. If you are not using that multiple thread at that time, response time will be more. Reactive system, constantly monitoring, more responsive to the user input. Graphical user interface application can interrupt a time-consuming task. So that's why I told any kind of graphical user, gaming or video or any kind of process which have that graphical user interface, it will take much more time. So in the meantime, what you can do, that you can load some other processor. In case of that virtual memory, so dynamic memory management. So one part, I no need to load everything at a time, on demand basis. So whatever the demand will be there, on demand basis, I can load that particular application. So by using this thread, what we can do, that we can parallelly execute each and every flow of that particular control, or that control flow from that program. We can divide it into multiple part. Whatever that part will be independent, and we can execute that control flow by one thread, so that parallelly all the thread will execute and it will take less time. Server can handle multiple clients simultaneously. Now you think of that, you have ordered some shoes from Amazon. Okay, so now it will go to that particular server. You are only not that particular person. You are not only that client A. There are n number of your friend A, B, C. Everybody is going to asking for this particular shoes. So at that time, first response, so in this one, if only one thread is there, so at that time your friend, you will not get that particular request until or unless you will finish your transaction. So for that reasons, what happen, it will create multiple threads. You have the Tomcat server. So I hope so that this Tomcat server, it's going to be used in servlet application. So the Tomcat, it's providing at a time by default 50 numbers of thread it can create. That means same instance. So 50 numbers of instance it can be created. So 50 numbers of people by default, I'm talking about by default. So 50 number of customer can at a time go for that order. So they will not be stuck with only one order. So this one only, that server can handle multiple clients simultaneously. So So simultaneously A is in client B, C, so like this n number of clients will be there. So all those clients, it can be satisfied with the help of this thread simultaneously. So A will be using, so there will be thread pool will be there. From that thread pool, it's a task of server. In server, there are container is there, different types of containers is there, which is going to define that how many numbers of what you call that thread has to be create, whether one thread has to create or two or three, or depending on that requirement, it's going to create that many numbers of thread. And each client simultaneously can access one thread, or it will satisfy each of those particular client. Each of those particular client, it's going to be satisfied by those thread. So and for that reasons, what will happen? Same time, n number of people can execute the order. So if I have to go and mine only will be satisfy, other a client will, what other customer will wait until or unless mine order has not executed. So at that time, no one is going to visit that Amazon website from that next day only. So this way, it's creating multiple numbers of threads to satisfy customer requirement. So this is that another advantage. Now can take advantage of parallel processing. As you know that parallelly it can execute multiple numbers of thread. Now, these are that few of the things. So the different process do not share memory. So here another important term, different process do not share memory space. As I told that thread, it shared memory space, but process, it's not shared memory space. Process creation will take much more time because I have to allocate the memory for that process. But for thread creation, it will not take much more time because it can share that same memory space. So it will take less time. So that is that one of the most important difference in between that process and thread. So what is the difference? As we told that process, thread, it's nothing but it's a lightweight process. Creation of process will take much more time because I have to create, I have to occupy that memory. So it will take more time. But in case of that thread, it's sharing that same memory space. I no need to go for extra memory. So it will take obviously less time. A thread can execute concurrently with other threads within a single process. So for that multiple process, in case of that multiple process, that the execution multiple processor is required, but thread, it can share that same one single process. So it's easy. Now, who is going to create those particular thread, or how all those things it's going to be defined? This is only by that JVM, our Java virtual machine only going to define. All thread is going to be managed by JVM, share memory space, and can communicate with each other. Thread communication, you know that inter-process communication, one process or thread communication. One thread will communicate with other thread. So in this way, a number of thread communication, it's that there's that message passing, IPC, inter-process communication. So it's the task of that JVM, how the message has to be passed from one thread to another thread. So already told this one. So this much is clear. What is thread? Is that clear? What is thread? In very simple way, just remember this much only. If you are confused in a program, there will be n number of lines will be there. So control flow, this is nothing but kind of program is executing one by one. First this line, this one, so like this executing. For example, this part is independent and this part is independent. This one is doing one task. For example, this is printing character A, and this is printing, this code is responsible to print number 1 to 100. So both the task is independent. So this one will be executed by one thread, this one will be executed by another thread. Just remember this much. This one will be executed one thread and this one is going to be executed by another thread. Advantage is what? If only one thread is there, so at that time you can think by seeing the length of this code only how long time it will take. But right now now this part is by this one and this part is this one. As we told that one CPU can execute multiple thread at a time. So parallelly we can run T1 as well as we can run T2. Parallelly we can run T1 and T2. So this time is going to be reduced. Previously if it was taking 10 minutes, right now it will take 5 minutes or some other minutes according to the time complexity if you'll calculate. So this is that advantage of multiple thread. Is that clear? So this is nothing but it's a job. This one will be defined as a job. It's a job to print character. This is the job to print integer number. Is that clear? Am I clear? Am I clear?